Okay, objective number 2, determine if numbers are irrational. First thing here on the note says all numbers fall into 2 categories, rational or irrational. How do we know if a number is irrational? Well, here's the basic thing right here. Let's see. An irrational number is a number that has a never-ending and a non-repeating decimal. So never-ending means like if it was 2.7138596, it doesn't end and it doesn't repeat a pattern, then it's definitely irrational. Pi, it might be a number by this time in high school. Maybe you know pi is one of those numbers where like it goes 3.14159 and then on and on and on, and it's just chaos and it never repeats a pattern. So pi is irrational. Consider that like the king of irrational numbers. So if you ever see the pi sign, even if it's in a fraction, like pi over 6, irrational. Or 3 over pi, irrational. If it's any bit in the number, pi is automatically irrational. Now what about rational? So what makes a number rational? Basically, if anybody ever said think of a number, you're thinking of a rational number. Like normal numbers, like the numbers on the calculator or the numbers of your sports jersey, 2 or 3 or 5 or 21, all rational. Even negative, like -2 or -5 or -6, those are also rational. Just regular numbers, 0 is rational. If it has a fraction like 3/4, totally rational, or 1/5, rational. Even -6/7, those are all rational. So all fractions that are just made up of integer over integer, those are rational. There are some fractions. I'm not saying all fractions, just fractions with nice normal numbers like this. If that fraction, say, had the old pi sign in it, like pi over 4, this pi sign, it's irrational, right? That's not a normal fraction. Anything pi is involved in is not normal. Any number where the decimal stops. So let's say you have a decimal 2.63 and that's it. Well, that's rational. So you can have a decimal. If the decimal stops somewhere, it's rational. Or if you do have a decimal that goes on forever, if it's a pattern like 3.6717171, that's rational. Or maybe if it's just like 5.333333, that's considered a pattern too. Also rational. So that's it. Either it has no decimal at all, rational. Or if it's a fraction without the pi sign or anything weird in it, rational. If it is a decimal that stops after 2 places or after 3 places, it's rational. Or if the decimal does a pattern, 61616161, it's rational. If your job is to like sort out and find the irrational number and like let's say got a police lineup of numbers here and you're supposed to say which one of them is irrational, there's 2 things to really look for. Where do these irrationals come from? One is anything with the pi sign in it, you don't have to think about it. It's irrational. So if you see that, it's irrational. The other one is from what I call weird square roots. All right, so let me tell you what a weird square root is. Hopefully you know what a square root is, but basically a square root, if I said square root of 25, that's saying what number times itself gives you 25. Well, this is a normal square root because 5 times 5 is 25, right? Perfectly normal. Also, say square root of 64. That's a perfectly normal root, right? Because this a square root, what number times itself is 64? It's 8. So 8 times 8. There. But what a weird one would be is, say, what about the square root of 67, right? So here's how you know what a weird one is. When I hit enter, I want it to say a nice number, like 5 or 8 or 7 or 9. When I hit enter on this, I'm going to hit this button right here, and you're going to see, it doesn't say anything. It just says square root of 67. To me, that's weird. If I put square root of 67 in my calculator and hit enter, and it says square root of 67, that's what Jones says is a weird square root. This is irrational. And let me show you why. Remember, irrationals have a never-ending decimal like pi? I'm going to hit the toggle button, and you're going to see that this goes 8.185352772. At no point is this a pattern. You can try to make one up out of your head and be like, but it said 535. No, it's got to be like a 535353535 right there. So that's not a pattern. Weird square root right here. So this is irrational. That's supposed to say IRR. Okay, so let's look at these 3, and then let's move on here. All right, which of the following is irrational? So you're looking between 2/7, looking at this one here. 2/7 pi 0.6343434434 and the square root of 121. So you might think the square root of 121, you might say, hey, is that one of those weird square roots? It's not. You might not know it. A lot of students might not know it off the top of your head, but when I hit enter here, this is going to just say a nice number. It's 11, right? Maybe you didn't know 11 times 11 is 121, but you do now. That's a decimal pattern right here, right there. See that guy? Anytime you got pi involved, who's irrational? He's irrational. So that one's out. Second one, which of the following is irrational? I'm looking for the pi sign. Let's see, well, negative 1 over square root of 9, no. Negative square root of 4, no. 11, no. 3.14, now, don't be fooled. 3.14, sometimes people think of pi as 3.14. This is just being mean. This is like fake pi. Fake pi is totally rational. If it says 3.14, it is rational. So this is not what we're looking for. You're looking for these three roots and say which one's the weird one. And don't even look at the fraction. Which one is the weird one? So here's square root of 9. Just look at the square root part. Is that a weird square root? No. Square root of 9 is 3. So this is really just negative 1 over 3. So it's not that one. Negative square root of 4. Okay, it's got some funky stuff here, but you should know what's 4. It's 2 times 2. So this ends up just being like that. The root part is just 2. So that would actually be negative 2. Here's the weird one. There is no number that you can multiply by itself and get the square root of 11. That's a weird square root. What's irrational? It is. Watch what happens when I throw square root of 11 into my calculator. Second square root 11. Hit enter. It's a square root of 11, man. It's weird. When I put something in my calculator and I hit enter and it doesn't change, that's weird. And it's weird because it's irrational. Last one. Which of the following is an irrational number? Let's just go one by one here. 1 over 11. If it's a fraction with normal numbers, it's perfectly rational. That's not why I circle that. Don't circle that. That's rational. It's good. Square root of 49. Is there any number you can multiply by yourself or by itself and get 49? Yeah, 7. Nothing irrational about that. What about this? Square root of 15. Is there any number you can multiply by itself and get 15? No. 5 times 5 is 25. 3 times 3 is 9. And 4 times 4 is 16. That's close. This is the weird one. This is the weird square root. I'll throw it in the calculator and let you see for yourself. The square root of 15 is the square root of 15. So that's the weird one. Just for the heck of it, let's see what D would have been. D just said 0.380. Hey, decimal patterns are totally rational. So last thing before we're done here, just think of the trick. When you're asked to find an irrational number, if you see the pi symbol at all, it's that. Otherwise, look for a weird square root. I don't care if it's in the denominator or in the numerator. I don't care if it's right of a negative sign. Which is the weird square root that you'd put in your calculator, hit enter, and get out of your calculator. And that's it. That's basically it. Your job is to find irrational numbers, looking for pi symbols, or looking for weird square roots. That is objective 2.